Okay, third example. I'm sure that's enough. So, same start. So we need the auxiliary equation. This is actually the same one we had earlier. So you could just put that to calculator. Anyway, that gives m is 2 or m is 3. And so from there we get the complementary function. Remembering what they're all called quite well, I think. So that's a e to the 2x plus b e to the 3x. And then to find the particular integral, we've got f of x equals 3x squared. And so if you go to your table, so quadratic, you use the quadratic form for the particular interval. So y is equal to, if you really hate all these Greek letters, you don't have to use them. You can use p, q and r, really doesn't matter. Lambda plus mu x plus nu, my nu's aren't brilliant, x squared. And then it's the same process. So I'm differentiating once, which lambda's going to go, so I get mu plus 2 nu x, and then differentiating again. So the mu's going, and so I get 2 nu there. You can look up in nu online, see what it really looks like if you want to. And then substituting into the left-hand side, so we end up with 2 nu minus 5 lots of mu plus 2 nu x plus 6 lots of lambda plus mu x plus mu x squared, and we want that to equal 3x squared because this bit here will equal 0. Excuse me. And so we need to essentially equate coefficients again. So I'm going to pull out the constant term. So 2 nu minus 5 mu plus 6 lambda. That bracket's not doing anything really, but I'm just letting you see what's there. And then x terms, I've got minus 10 nu plus 6 mu. And then x squared terms, I've got none there, I've got none there, and so 6 nu x squared is equal to 3 x squared, and then we equate coefficients. So it makes sense to start with the x squared coefficients, and that gives you that 6 nu is 3, and so nu is equal to a half, and then x coefficients, 6 nu minus 10 nu equals 0, and that gives you, that's going to give you 5, and so mu is equal to 5 over 6, and then the constant term, which we could just call c, couldn't we? So 2 nu minus 5 mu plus 6 lambda is equal to 0, because there's no constant on the right hand side, and so you end up with 1 minus 25 over 6 plus 6 lambda is 0, and lambda comes out as being at 19 over 36. And so the solution to this non-homogeneous second order differential equation, the general solution is that y is equal to a e to the 2x plus b e to the 3x plus the particular integral. So it's plus 19 over 36 plus 5/6 x got where I am now, and then nu is a half, so substituting into there, so plus a half x squared. Two constants of integration because it's a second order differential equation. So this bit here is our particular integral. And yeah, if you chuck all that into there, you will get 3x squared. You don't need to do it, but you will, because this bit comes to 0, and we've just shown that this slot here gives you the 3x squared that you need.